Hi everyone, my name is Yash and today I will be presenting the Physics 20 to 12 Lab 1 experiment. As far as the introduction goes, the purpose of this experiment is to observe interaction between charged pieces of tape to determine excess charges. And then for the model, we're just using tape to model point charges, and we're going to use Coulomb's law, F equals K, Q1, Q2, all over r squared, and Newton's law, F equals ma, to determine excess charge on tape. So for as far as the experiment goes, we're making a charge tape, and we can define the system as two pieces of tape, tape A and tape B, and then the surroundings can be the desk and pretty much everything else. And the conditions are just going to be that we need two charged tapes and a base tape that is neutral so we can have like a standard surface to put the other two tapes on. As far as the procedures go, tape B was put on top of the base tape and then quickly removed, which means tape B either lost or gained electrons in the process. Then the tape was placed near other items like a pen and my hand to determine the sign of the charge. The final step was to put tape A over tape B until the tape floated a bit, and the distance between tape A and B at the time of floating is measured. So the results of the experiment were that the U tape was repelled by another U tape, the U tape was attracted to my hand, and the U tape was attracted to a negatively charged pen. And from this, we can conclude that the U tape is positively charged and displayed a loss in electrons because opposites attract and like repel. As far as the data and calculations go, the length of the tape was measured to be zero point 0.2 meters, the width was 0.019 meters, the mass was 0.00015 kilograms, and the distance between the two tapes at floating was 0.029 meters. And the force of gravity can be measured by a simple F equals ma equation, and with that we get a value of 0.0014715 newtons. And then the charge on the tape, we know that the electric force and the gravitational force need to be equal because the forces need to be balanced. So with the quick rearrange of the equations, we get a value of 1.17 times 10 to the negative 8 coulombs. And then to find the number of electrons lost, just divide the charge of tape by the charge of the electron, and we get a value of 7.33 times 10 to the 10th electrons. And further calculations were figuring out the area of the tape, which is simply just the length of it times the width of it, which was 0.2 meters times 0.019 meter, and that gives us a value of 0.0038 meters squared. The area of the atom is 1.1 times 1 times 10 to the negative 20 meters squared, and the atoms on the sticky surface is the area of the tape divided by the area of the atom, which is 3.8 times 10 to the 17 atom. And then to calculate the ratio of electrons to atom, just divide the number of electrons by the number of atoms, and we get 1 electron for every 5.2 times 10 to the 6th atoms. And then here is the code that I wrote to model the experiment. You can see that we have a gravitational force pointing down, an electric force pointing upwards. That's equal in magnitude. And then the charge, the deficiency of electrons, and the ratio for electron to atoms, as calculated here, is the same as what I got from my experiment. And as far as the discussion goes, some possible errors might have been there. The measurements related to like some of the things like the charge or the length of the tape or the width of the tape could have been a little inaccurate, and my hand itself may have impacted the charge on the tape. To answer the question, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tape and other charged objects? I don't think any of the observations I made would change because at the end of the day, opposites attract and like repel. And then to answer the question why it's important to handle the charged tapes as little as possible, and what happens when charged tapes come in contact with your hands or other objects, you don't want to touch the charged tape too much because your hand would give some type of force to it, and that would deviate from the actual calculations we want to figure out. And yeah, As far as the conclusion goes, I realize that the data from experiments can be faulty because there's a lot of sources of error, and that it's better to repeat experiments multiple times to get really valid results. And then electric and gravitational forces are all around us.